today's webinar. My name is Christina and I will be your host today. This is the third webinar in our series of in-depth webinar focused on the key themes, features of the SDL Tridion Sites 9 content management offering. This webinar will focus on how SDL Tridion Sites cloud deployment works. We will walk through the following elements in this session. Benefits of running SDL Tridion Sites cloud solution. A deep dive on how we achieve high availability, auto-healing, auto-scaling, upgrades. A sneak peek on what we are working on post SDL Tridion Sites version 9. Today's speakers are Likhan and Kalpik. And now I will pass it over to Likhan to begin the presentation.
Hi everybody and welcome. As Christina was mentioning, today we are going to go over the cloud offering of Tridion Sites 9 and what we are basically planning and how we are achieving the couple of topics that was mentioned and very interesting for cloud. Today's session, it's going to be me, Likhan Siddiquee. I'm the architect for Tridion Sites, and joining me today is...
Hi, I'm Kalpik. I'm the senior cloud engineer, and together with Likhan, we define the architecture and roadmap for the cloud.
So what are we going to discuss today is what is Tridion Cloud, what are the benefits of running Tridion in our cloud offering, along with a technical deep dive on how we achieve the principles that actually ties or the benefits of running in a cloud, and then followed on by a Q&A.
So before we move on, we're just gonna trigger an update to a stack.
Yeah, so I think as we mentioned that what we are going to show today is how we upgrade stack in Tridion, how we do high availability and scaling of the cluster. But because upgrade takes around 20 to 30 minutes of time, so what we're going to do right now is just trigger an update of a stack, and then later on we will get into details of what actually happened behind the scene. So yeah, Copy, can you trigger that?
Yeah. So this stack that we have here right now is actually running an internal version of UDP that is 10.1. I'm gonna upgrade it to another internal release that's 11.0.
Yeah. So while it's upgrading, we'll get back to the presentation, but I think what is interesting to mention is that we have created two identical stacks on the same version so that we can post the upgrade, we can compare actually what happened. Right, so Copy, want to take it off?
Okay, so coming to what is Tridion Cloud, yeah, it's basically our offering running in our product running in our own cloud offering. And this is architecturally what it looks like. So this slide details the cloud deployment architecture for the content manager. As you can see, it's basically so our offering is based on AWS cloud, and everything runs inside a VPC. And here you can see for the CM side we have two roles. So one is the CM web role, which is basically the UI, and the other is the CM publisher, which does all the publishing. So these two roles are basically a set of servers that can scale based on demand. And of course, there's the database, and the publisher actually talks to the CD deployer to publish the packages. Moving on to the next slide.
I think before we move on, maybe, so what are the different roles? So as Kalpik mentioned, so we have the CM web and the CM publisher. The publisher is, as we all know, it's just the publisher. There is nothing additional running in there. But the web contains all the rest of the components, be it the core service, be it the UI, translation manager, and all of those things. So when we were designing it, we thought that, okay, the publisher is something that we want to scale standalone, and that's why it's in a separate component. but the rest of the pieces, so the core service, the UI, all of them, they scale together. That's how we choose to do it.
Okay. This is the architecture for the content delivery side. As you can see, it is a bit more expanded. So in our cloud offering, we offer two topology types, that's live and staging. And as you can see, there are two roles. So essentially, one is the deployer role, and the other is the content role. And again, these are a set of scaling servers. The CM web role, as you can see, the publisher side actually talks to the deployer via the load balancer. So there are also two load balancers. One is on the deployer side, and one is on the content side. And the content load balancer is basically accessed by the presentation layer, which can reside either on our own cloud, or it could reside in any other cloud such as Azure, or it could be any hosted on the corporate data center of the customer. And again, coming to the database side, we have master slave replication to ensure high availability for the database.
And also for the roles here, as you can see, the content, it's only mentioned about content service here, but actually this exposes all the service which is necessary for the web application to work. So this contains content service, contextual image delivery, the XO related services, the context service. So all of those are in this role. But yeah, FYI, so this is what we have right now. But yeah, with Sites 9, we are moving to a new model.
So as you guys must have heard on the previous webinars that we're moving to the unified delivery platform. So in the cloud architecture also there are quite a bit of changes. So we are moving to a containerized deployment architecture. So here you can see an auto-scaling ECS cluster. So this is basically the cluster which will host all your containers. Then every layer here is actually a service. So it could be one could be a content service, the other could be a discovery service, context service, and so on. And the service is itself basically a set of auto-scaling containers, and there's a load balancer in front of all these services, and we do path-based load balancing. So in our earlier offerings, we were running every service on a different port. Now we don't do that. It's all the services are sharing the same port, but the load balancer is intelligent enough to decide which request goes to which container. Then you have some shared Efs storage here on the top. This is basically used to store the deployer packages so that the deployer can, every container running on different ECS hosts can actually have access to the same deployer packages. You have an SQS queue, which basically manages the orchestration of these packages, which package gets picked up by which particular container. And of course, we have the master slave database. So this is the setup as it looks like for one particular customer. So this cluster itself is capable of hosting multiple customers, and every customer will get their own set of database and load balancer to maintain isolation.
Yeah.
Yeah. So that is what it is, and every service itself is basically auto-scaling based on certain rules. So, for example, the content service, we scale based on the number of requests that is coming to the content service, and the deployer, for example, we scale based on the number of packages that are waiting in the queue. So we have sort of come up with different scaling rules for different services depending on what is the best way to scale that particular service. So every service can essentially scale independently. And of course, we have high availability, and we have basically instances running in different availability zones, which is essentially different data centers of AWS, you can say.
So I think what is also interesting to mention here is that we're leveraging ECS for the container scaling, for the container orchestration. And when we are putting the cluster in multiple availability zones and we are running containers in there, the ECS is also ensuring that the different containers are actually running on different instances of the cluster rather than on a single cluster, ensuring resiliency of the service.
Yeah, we can show that in a bit, but let's move on for now.
So couple of things that whenever we are looking, especially not only in the cloud, but Tridion going forward as well. So the couple of design principles that we always keep at the back of our mind is to ensure that the services are capable to run on a highly available fashion. So we are moving to rather than a master-slave replication or basically a standby to actually a fully highly available so that both of them can actually work. You can already see that that principle is also already available with our deployer. Previously we couldn't do that, but right now we can. And also any services, they should be able to elastically scale up and down without any service downtime. Anything that we do needs to be repeatable so that there is practically zero manual intervention. Anything that we build should be highly resilient so that any failures, it's not actually bringing down the service itself, but yeah, it might be an instance. So if you quickly go back to the previous picture here, you can see that we are deploying the cluster across multiple availability zones, and each services, as I mentioned as well, are also running in multiple availability zones. So when a deployer is running, so we have two instances of the deployer. One is running on availability zone A, and the other one is running on availability zone B. So in case of a complete failure of an availability zone, we will still be fine because yeah, the other one on the second availability zone should be working. Then the other thing that we are concerned about is again indeed the security. For security, as Kalpik mentioned, we have isolation which are in place. Right now, the customers are actually even running with their dedicated accounts. But even if we are not running with the dedicated accounts, it is still fully secured because all of the services are secured using the security groups in AWS. And then, yeah, anything that we build needs to be modular and extensible. So if we go and look into the deployment of our microservices across the cluster, what you will see is that the only thing that is different among them are their scaling policy and the images, but the rest of the CloudFormation scripts and everything is basically the same, shared across all the services that we are running. And yeah, so just a sneak peek onto the technologies that we are leveraging on AWS is basically we are trying, rather than creating our own, reinventing the wheel, we are trying to leverage the possible services that are already available. As I said, so we are using ECS for orchestration of the containers. We are using EFS for file storage. We are using the RDS for databases. So anything that we can acquire as a service, that's what we try to do rather than actually building anything ourselves. Now, going on to the benefits, what we will try to do, hopefully, again, the demo gods will be with us again today. Rather than actually talking about it, we are going to try to really show and show it really in action about how we are achieving all the benefits that we mentioned previously: high availability, scaling, resiliency, and upgradability. So we're going to show them all live. With that, I'm going to hand it off to Kalpik to drive it.
Okay.
Do you want to quickly go to the high availability, the availability test that is running, just to give a sneak peek because we were upgrading. So at the beginning of the demo, we started an upgrade, you remember. So what behind the scene, what we have is, so if you go to the availability test.
So this entire stack is getting updated right now. And we're actually running an availability test on Azure, where it is actually pinging our DXA, which is the sample web application. It's actually pinging it from 16 different locations. So it's pinging the DXA, it's pinging content service, and it's pinging the discovery service. You can see while we are actually upgrading UDP from one version to the next version, we are doing it while this thing is actually pinging the services. So you can see, even though the upgrade is happening in the background, there is no loss of availability for the site.
Not yet. So let's hope that while the upgrade finishes, the graph still stays green. We don't see any red dots.
Yeah.
So moving on.
So okay, so this is working. So in the meantime, we'll go back to the slide and see what all we can demo. So the first benefit we want to show you is basically high availability. So going back to the internal, so here you see our cluster, and as I said, we have these various services. So if I filter down on one service, so for example the session service, which is the session aware content service, you can actually see that there are 2 running tasks, and if you actually filter on the tasks, you can actually see it is actually running on 2 different container instances, and container instances are actually the EC2 instances where this container is being run. So you see there are two instances of the content service, and they're running on different hosts. So even if one of this host goes down, the service will still serve requests from the other host. In the meantime, it will also recover and start up on a different host. So this is what we mean by high availability. So all these concepts actually apply to the service itself and also to the cluster. So if you see the cluster itself, it's actually running 6 instances. So this entire cluster is basically comprised of 6 instances which are running these various services. So we have redundancy at all the stages, at the infrastructure as well as the service.
Yeah, and they are also spread across multiple availability
zones. So if you see here, there's 1A, 1C. So 3 are running on availability zone 1A and 3 are running on availability zone 1C.
Yeah, and this is also taken care of by the ECS itself. Whenever the cluster is scaling, it's going to ensure that it disperses the load across availability zones.
Yeah. That was high availability. Auto healing. Okay, this is an interesting one. So let's go back to the session service then.
Yeah.
Oh, let me filter on the tasks. So I have two tasks running for the session service. So if I just stop this task, which will kill the container. So now if I go back to the service, you'll see the desired tasks is 2, but the running tasks is 1 because I just killed one. If we just wait for a few seconds, ECS will basically discover that one container has exited somehow. So when will a task exit? There are multiple ways. So one is loss of a cluster instance. So that could lead to the stopping of one of the tasks. The other is maybe the service itself encounters some error and the process exits. And when that happens, again ECS will discover that the task is not there. And if you see, it's already trying to start up a new task. It's in pending, so it's basically starting it up. And as soon as it's running, you'll see back here that it's again running tasks is 2. So the session service has recovered.
And yeah, all of these are also running behind load balancers, where the load balancer is also actively monitoring the health. And whenever it detects that a task is unhealthy, it's going to start rerouting all the requests to the running one.
Coming to the next one, auto scaling. Okay, so here we see that the session service is running 2 tasks. What I'm going to do now is I'm going to start a load test, wherein I'm going to hit my DXA site, which will in turn generate traffic on the content service. Okay, starting up. Yeah, so this will generate traffic on my content service, and what that will do is basically based on when it passes a certain threshold, it will tell my cluster, okay, I need more containers of this service because it's experiencing high load. And what the cluster will do is it's going to orchestrate another cluster and then load balance the load between three or four containers instead of 2. So how this works, let me show you. I've already triggered the test. Let's check my load balancer. Yeah, no, the content service. Yeah. Okay, so let's check my requests. So you see, you should start seeing some requests coming to the load balancer soon. As soon as this test ramps up. Right now it's only at 4 or 5 requests per second. Okay. Give it some time. Okay, it's ramping up now. Yeah, so you see I've already seen a sudden hit on my target group that is routing the request to the content service. I'm already seeing this. This should in turn tell my cluster that okay, I'm getting a lot of hits. Now I need more services to load balance to. And hopefully in a minute or so, yeah, you're already seeing it's already scaled up to 3 tasks. And in some while actually we'll see that it actually even goes up to 4 tasks. So this has in turn what it has done, it has now started 3 containers of the session service. Yeah, here we see those 3 containers. And the load balancer is now balancing the load to all these 3 containers instead of 2. So it's so the response time on the site does not suffer. Okay, so that's the scaling part. Rolling upgrades. Okay, so this is an interesting topic. So what we are trying to achieve here is basically an upgrade from one version of UDP to a next version of UDP. So like I showed you in the beginning, let me check if my stack has finished upgrading. Yeah, so it says the update is complete. So I had triggered the stack update. What it did was basically so all our containers, all our services are individually packed into individual containers. So we have containers for example, for discovery service, for content service, for context service, and so on. And the way we actually mark a container as released is basically we tag it a release version. And what I did was here was I upgraded from an internal release which was tagged as 10.1 to the next release which is tagged as 11.0. So I had already showed you when I triggered the update, and now the update is complete. Let's look at the availability. And it seems that my site has been available. So there were a total of 4,500 hits on the site in this time, and basically it did not fail. So essentially I managed to upgrade Tridion from one version to the next version, at least the UDP side, without having any downtime on my site.
Can you navigate to the DXA application that's actually running, the one that we are monitoring?
Yeah, so this is my live site. This is actually running, and this was essentially running while I was upgrading my Tridion.
Yeah, so we didn't upgrade the web application itself, so the DXA application is still the same version. What we did was we upgraded the UDP stack behind the scene. And it's because of the design principles that we talked earlier, with high availability and with rolling upgrades, what we have achieved is that the site actually was live all the time when the upgrade happened behind the scene. So with high availability, we already had 2 services. What this update did was it orchestrated so that it always has these minimum 2 number of services. So it spun up a new version, so making it 3 running services. And then once the 3rd one came up healthy, it deleted the old one, and then basically over time it replaced both of the services with a newer version. But with the as I think what we have tried to achieve since the release of Web 8 at least is that from 8 onwards we support rolling upgrades. So essentially an application or the services can actually talk to the same backend database. So we can upgrade the database in one go, but then the application, there are 2 versions of applications can simultaneously run on that same database. And by enabling that, we can now do rolling upgrades of the application itself and the services without any downtime.
Essentially what Likhan was talking about, this is how we achieve it: minimum healthy percent 100%. So it will so when we say we need two containers running, so it will ensure that 2 containers are healthy 100% of the time. And when we trigger an update, what it does, it actually starts a container of the upgraded release version. It starts it up, waits for it to become healthy. Once it's healthy, it actually starts directing traffic to it, and it marks the older instances as draining, and then it waits for the connections on the old instance, old container to end, and then it basically removes that old version. And that is how we achieve rolling upgrades.
We have some time. Can we probably just downgrade that stack and then maybe see this in action?
Okay.
So what we will try is we will, on the same stack, we will just try to now downgrade the stack to the older version and see how that goes. So we'll just do the opposite of we did initially. And as Kalpik mentioned, so the way we do it is by tag. And now Kalpik is updating the tag.
Let me, so to make it a bit clearer, let me show the task definition.
We can see the running tasks as well, right? Because the running task is going to go to 3. And
no, I wanted to show the tag. So here, if you see in my pop-up, it basically says content service : 11.0.0 snapshot. Yeah, so this is running version 11 of this particular container. And now what I'm going to do is I'm going to downgrade it. So from 11, I'm going to say 10.1, which was the previous release.
FYI, so we support rolling upgrades, but not rolling downgrades.
Yeah,
it works.
This is unsupported.
This is something unsupported. But indeed, what you can effectively do is, because it supports rolling upgrades, you can have 2 versions of that running simultaneously. So that is something that we allow. And how you achieve it, that's not the problem here.
So we're going to wait for a bit for the stacks to start upgrading.
Yeah, so what is happening now behind the scene is once Kalpik changed that value, so what we have is we have a prerequisite stack, and the prerequisite stack is responsible for the configuration as well. So it's now going to first update the configuration, and once the configuration update is complete, then it's actually going to start triggering the actual stack. So it's going to take probably a few minutes for the prerequisite stack to be upgraded.
So just to clarify, when Likhan mentioned configuration, it's actually the deployment configuration and not the configuration of Tridion itself.
Yeah. Well, it's happening. Can we then see how because you also mentioned about the cluster.
Yeah.
So what happens when the cluster goes down? Can we trigger something for that?
Let's check that. I'll not touch the stack that's upgrading. Let's look at the other cluster.
Maybe you can open it up on a new tab and keep the tasks here.
Yeah. that. Yeah, so it's still 11. So this is my cluster. It has 6 ECS instances, if you can see. What I'm going to do is go to EC2 and just kill one of these instances. Okay. I go here. This is one of the hosts that is running my containers. What I'm going to do is I'm going to just kill it. Let's check on our stack, which was upgrading. Upgrade complete on the prerequisite stack. Okay, so now you can see it's actually triggered an update of the other services. And now, hopefully in some time, we should, if you refresh this task definition.
But can you go back, because it's probably interesting to monitor the running tasks as well, right?
Yeah.
Because then we can see the 2 different tasks.
Yes. So it's only 2 right now. Yeah. So you see now, when I triggered this update, so desired task is 2, running task is 4, because 2 of them are new and 2 of them are old. And what this is going to do is, as soon as the older ones, in this case, because we are doing a downgrade, so as soon as the older ones register as healthy, it's going to delete the new ones.
So probably, can you go to the target group and we can see what's happening over there on the load balancer?
What do you want to show?
So if we go to the load balancer, because now we will see 4, right?
Yeah.
And then it's going to, once it finds the new 2 instances healthy, and only then it's going to drop it back.
Yeah, okay. Staging alive.
Yeah.
Yeah, so these are showing up as unhealthy. But as soon as they start accepting traffic, they will turn up as healthy, and the other 2 ones will be deleted. And if you see here again, they are distributed across availability zones: 1A, 1A, 1C, 1C. And what else are we showing?
The cluster. We are jumping back and forth,
yeah,
because we are showing quite a few different things simultaneously.
Yeah, I think there was enough capacity on the cluster too. Let me kill another one. Let me kill another one.
Kill 2.
So as you see, actually the cluster is actually rebalanced. So it says pending task 0. So it has so whatever tasks were running on the cluster that the host that I killed have actually jumped to other hosts, because they still had available memory and CPU. So yeah.
Kill another one. Oh yeah. I think 1 is already back up.
Yeah. So if you see, I killed 2, so it should have been 4, and now it's again 5. And if you see, this is the new one because it has 0 tasks running. And in some time you will see that the cluster will again rebalance itself to ensure better resource utilization. You see, there's 1 task that is pending, so this is the task that's probably jumping hosts. And that will come up on the new host. Jump again. Yeah, so you see it has now turned up healthy, and now it's draining the other, the older containers. So so draining basically means the load balancer gives the container time to finish processing the requests that are in flight, basically, so that you're not dropping any connections while, for example, if someone is, your presentation server is actually making request to content service, we don't want to kill that request. We want the content service to finish serving that request, and only then we will terminate the connection.
Go back to the ECS for this, not this one, where we had
the services.
So where we had the task for the session, right? So we
Yeah.
were looking.
So we're already seeing it's running now 68 tasks because it's running essentially double of all the tasks, 4 times. Some services have already stabilized to 2. Some are still coming up, and as soon as they become healthy, they will go back to 2 tasks.
Can you just search for the session 1? Let's just focus on 1.
Yeah.
Yeah. So it's going to take a while, as Kalpik mentioned. So for the instance to actually be marked healthy completely, and then the old ones to be finished draining, and then it's going to dial back down, and also the cluster is going to rebalance with distribute all the containers accordingly. And if the cluster also needs to scale down, it's going to scale down.
Okay.
I guess I think that's all that we wanted to share. Probably what is also interesting is that this similar principle we are also trying to apply on the content manager side. But yeah, running containers with Windows containers is still not that, how do you call it, production ready. But we can probably take a sneak peek, right? So this stack, this is also running the Windows, the CM side on Windows cluster, right? Okay.
Yeah. So both these stacks are actually running CM also on the Windows on a Docker containers basically instead of EC2 instances. So we do have this Windows cluster. The reason we have 2 clusters is basically because Docker does not yet support having 2 different OSs on the same cluster. So we have to have a Windows cluster for the CM containers, and we have to have a Linux cluster for the CD side or the UDP side. But you see here the Windows cluster, and it is essentially has all the services which are containerized. For example, publisher service, the CME, the batch service, workflow, so on and so forth.
Yeah, and here you can actually see that, as I mentioned at the beginning of the demo, that we were running 2 stacks, one which we actually triggered the upgrade, and the other one where we were seeing the scaling and the healing of the services. But for the Windows side, you can see here that they are running on the same cluster. So one of them is called fixed webinar, and the other one is scalable. The only reason why we named it is so that when we are demoing, we understand which one do we want to scale and which one do we not want to scale right now. But yeah, so this is really a proof of concept that we are running. We are encountering quite a lot of issues at the same time, and we are trying to address them. So this is not something that we can promise that we are going to deliver in scope of Sites 9, but this is something that we are actively working on, and hope that sometime in the future we will be able to finish everything up, and then also basically allow CM side to be running on containers fully.
Yeah, that will achieve all the benefits that we just demonstrated for the UDP side. That it will basically be the same for the CM side then.
Yeah, well, we can already do some things like that, right? So here we can also kill a task, and then it's going to come up. Yeah, it's going to take a bit longer because the Windows containers are also bigger. But yeah, that's not something that we are in control. It's just the Windows. It's a Windows thing, right?
Yeah,
so
Windows versus Linux thing. Okay. So
I think this one we don't need to wait, right?
Yeah,
it's going to take a while.
Time, but let me see. The task definition should have changed for now. Let me see. Yeah, this says 11 snapshot. I'm going to refresh it.
Now, can you reopen the task?
Yeah, probably.
Because actually the task changed, right?
So this one. Yeah. So if you see the actual tag on this container is now 10.1.0 snapshot. So essentially now we are running a older version of whatever the service, discovery service. Yeah. So that's how it works. Anything else you want to talk about?
I think that's about it for today. So we are going to open up the floor for Q&A.
Okay, thank you for presenting today. We are now going to open up the Q&A session. If you have any questions, please enter it into the Q&A box in the right-hand corner of your screen. We have a couple of questions here. So the first question is that possible all deployers commit writes at the same time, or only one will be writing and others have to read only?
No, so I think already with 8.5 we allow multiple workers to write simultaneously. So it's no longer a master-slave model. You don't need an active-passive failover scenario. You can have active-active deployers running. But for the deployer as well, what we did is that the deployer can also be split. So we have a deployer endpoint and we have a deployer worker. So you can even split them out. The endpoint is responsible for receiving the request and putting it up into the queue, and then the worker is actually responsible for handling the message and actually deploying it into the database. But you can have active-active.
The second question is, can you share some light on how licensing is handled in the case of auto-healing, auto-scaling, and rolling upgrades?
That's a very interesting question. I was not actually prepared to answer that. But for example, for our cloud, what we are doing is we have non-node lock licenses, and that's what we are leveraging right now. We are in process of basically acquiring or moving to a different licensing model. I can't really commit that we would be able to achieve that in scope of Sites 9, but this is something that we are also actively looking at to see if we can somehow have a seed-based license or an active license, so that with a local license server or a cloud-based license server, we can just say, okay, you can have 5 running instances, and then essentially without a node lock. So that's not something that I can really commit to, but it is something that we are actively looking at.
But just again, the demo which we showed was for, the Tridion cloud offering, so the offering that we offer. And in terms of that, so how we license our customers is mostly on container hours.
Yeah, so in our cloud, that is going to be container hours. That's nice of you to mention, Kalpik. But yeah, for people running on their own cloud, we still need a non-node lock license. Hopefully we will address that sometime in the future. And let's hope it's going to be in scope of Sites 9.
Next question is, how can customers or partners learn more about how to use AWS to achieve similar scaling and upgrade scenario as shown in the demo?
I think the technologies, or essentially the principles that we showed in the demo, is not something that is SDL Cloud or SDL Tridion Sites Cloud only. For example, the rolling upgrades, that is something that customers can already leverage, or from 8.5 to the upcoming Sites 9. But we have to keep one thing. So I like to emphasize on one key thing, because the rolling upgrade we are going to support only from the last released version. So although we will support upgrades from the last multiple releases, but the rolling upgrade is always going to work from the last major release. So if it was 8.5, you can upgrade to 9 from 8.5, but not from 8. So if you want to upgrade from 8 to 9 on a rolling upgrade fashion, then it has to be upgraded in 2 steps. But yeah, it still can be done. For example, for the high availability, that's something that we are making changes to the product, which is also available for everybody, like the deployer scalability that we have addressed in 8.5. Anybody can set up the services in a high available fashion. The content service, there is nothing really complex to set up on the content service. The publisher and the rest of the services, they can just scale on demand. Now, the scaling policies and the cloud formation scripts that we use for our cloud, that's something that is internal only. But yeah, maybe down the road we will have more opportunities to share more information about it.
Next question is, do you expect official container support for customers in CD or CM in the next release?
So this is also something that we are actively looking at. So the CM one, I cannot really comment on that because, as I said, so there are product issues that we need to address. There are infrastructure issues that we need to address. But our aim is to at least have the UDP containers available. It might not be on a public repo, but it might be on a protected repo which is accessible for our partners and customers. That's something that we are looking at. Again, I can't really commit that it is going to be available, but we are looking to enable that.
Okay. Next question, how does the services...
Before you continue, I think one thing I can commit to is that even though if we cannot really ship the containers due to some policies about artifacts not being available, we will at least share the Docker file. So that's something that is concrete. So if we cannot share container images, we will make available of the Docker files on a open source GitHub repo so that relatively easily people can build container images.
Okay. How does the services scale down automatically after auto scaling up because of number of requests?
Sorry, can you repeat the question?
Yeah. The question is, how does services scale down automatically after auto scaling up because of number of requests?
Yeah. So if you see, basically what we have is we have a scale up and a scale down policy. So it's, as I said, it's elastic. It has a threshold which triggers a scale up of a server, and if the threshold goes down, it actually triggers a scale down of a server. So it's all based on the threshold, and the threshold is different, and also the monitoring is different per service, as Kalpik was mentioning. For example, we are looking at the number of queue messages for the deployer scaling. If it is beyond a certain threshold, we add services to it, and if we see that the number of queue messages has gone down, we in-scale the cluster, or not the cluster, but the service. The same goes for content service, for example. We have a threshold on the number of requests coming to the content service, and when it's lower than a certain number, we scale down.
And again, just to add to that, so when we scale down, again, the principles of draining connections and all that is still maintained. So no connections are dropped. Actually, the container is marked to be scaled down, and then the load balancer just stops sending requests to that container.
The new requests.
Yeah, stop sending any new requests to that container that has been marked for scale down, and once that container finishes processing the existing request that it had, then it is basically removed, and that's how the scale down happens.
Next question is, how will it be working for on-premise installations?
Yeah, so as I mentioned, we will be at least sharing the Docker file. Hopefully, we will also be able to share the Docker images. And then we are leveraging ECS and CloudFormation for the orchestration. It actually depends on what kind of cluster scheduler people are using. So if people are using Kubernetes, most of these cluster schedulers actually has this capability already in there. We did not build anything ourselves. All the scaling and the healing and all these other capabilities we are basically leveraging out of ECS. And any cluster scheduler can actually also has these features. So Kubernetes, be it Mesos Marathon or ECS, or even Service Fabric.
Yeah, I think we've got a last question. The question is, if a whole availability zone goes down, will contents management functions such as add, delete contents continue to be available, or is it just about delivery continuing to be available?
So first of all, I think on the first slide, one thing was missing indeed. So the content manager database, that also runs on a multi-availability zone. So it's a multi-AZ RDS database, which means that the database is available and our service, whenever, I think it's not something that we have even, it's Amazon's auto scaling group. When you have, let's say, the CM role, if you are running 2 instances, on a region, the auto scaling group is going to ensure that the instances are running on different regions. So if a full region goes down, we should still have full capabilities available.
Okay, I think that's all questions we've got today. So I'm going to wrap it up the webinar today. So thank you for attending today's webinar. We hope it is useful and informative to you. We look forward to sharing the webinar recording with you shortly. Okay, have a great day. Thank you.